sub j such that we want y sub j to be larger than or equal to 0. Okay? So just y sub j, okay, without using squared. So if we define the new variables y sub j such that they are larger than or equal to 0, then we don't need to use the squared. Yeah, of course you can do that too, but in that way you will have the additional constraint. Okay? Yeah, but it's more tedious. So I think this way might be better, because if you just introduce like y squared, then you don't need to worry about like whether it's positive or negative, right? Because anyway, y squared must be larger than or equal to 0. Okay, so the lowercase g, this constraint is still satisfied. OK， 可以吗？反正就是你当然也可以，我刚刚说你当然也可以定义，不要用平方，只要用 y sub j， 然后但是要记得要多一个 constraint， 就是 y sub j 要大于等于0，这样就可以。但是那样的话有点麻烦，因为等于又多个 constraint，OK， 所以这样是更方便一些 ，right？ Okay, so now we have the new Lagrange function, okay, and because we have already transformed this inequality constraint problem into an equality constraint problem, then we can just use the method that we learned during the previous hour, okay? Define this L and then the list of conditions. And right now, because we have our Lagrange function is a function of x, y, and lambda. Let's just let's take the partial derivative for each one of them, okay, for each kind of variable. Okay, so over here we have n plus 2n variables and also n plus 2m equations. So we should be able to solve the problem, right? Okay. Yep. So let's see. I think I can also give you an example. Okay. Yeah. Okay, so a new, right? That's good. 哎，我怎么觉得颜色还是淡淡的 ？Is it? First one. Example. Let's minimize this. Oh, maybe better. Okay, now I think I'll use x1, x2. Okay, yeah, because I don't want you guys to get confused. Okay, so f of x1, x2 equals x1 squared plus x2 squared minus 3x1, x2. Okay, subject to the constraint. Okay, so let's say we have this kind of problem. Two variables and only one inequality constraint. So let's start to apply the method we have just learned. Okay. So we introduce y. Okay. So. Introduce a new variable y, okay, and define the capital G, okay. So the capital G. Oh wait, This capital G should be a function of x and y. Sorry, I forgot to put y. Okay, capital G is a function of x and y. Yeah. So G x, y. I'll just say capital G. So capital G becomes what? x1 squared plus b squared minus 6 plus small y squared equals 0, right? So that is my capital G, okay? Okay, so then let's start to perform the, let's start to use the necessary conditions to find the possible points for this optimization problem, okay? Yep, so let's use, maybe, let me try to use this, this color. I think it's a little bit too dark. Okay, so take partial derivative with respect to x1. We have 2x1 minus 3x2. Oh, let's first write down L. Okay, so now L. Do I still need to use the red color? So L now, L is a function of, I'll just write L, yeah. 只要写 L 好了, yeah. So L is F plus lambda. Right now there's only one constraint, okay? So only one lambda. Lambda times capital G, okay? Yep. And if you want to write down the whole thing, x1 squared plus x2 squared plus lambda times capital G x2 squared minus 6 plus y. Plus y squared, okay? So this is the L, and now let's take the partial derivatives, okay? So we have 2x1 minus, here's minus 3x2, and over here plus 2 lambda x1, okay, equals 0, and take partial derivative with respect to x2. We have 2x2 minus 3x1 plus 2 lambda x2 equals 0, and also partial derivative with respect to y. Yeah, with respect to y, we only have 2 lambda y, right? 2 lambda y equals 0, and finally, with respect to lambda, take partial derivative with respect to lambda. The only thing left is the constraint, okay? Okay, yep, so these are the, these are the equations we want to use. So as you can see, we have how many equations? 4 equations, that is, n, right now n equals 2, right? Do I need to write it down? Okay, n equals 2, n equals 1 in this case, n is the number of original variables, n equals 2, n equals 1, the total number of variables is n plus 2n, that is 4, right? So totally we have 4 different variables, x1, x2, y, and lambda, and we have 4 equations, so it is fine, right? Okay. Do I need to solve this for you guys? Let me just tell you the tip for solving this kind of problem, okay? Usually we start with this kind of equation, okay? Yeah. Usually we start with this kind of equation. Yeah, something times another equals 0, yeah. And with this kind of equation, it will be easier to solve the rest, okay? So let's start from, let's start from equation 3, okay? So let's say this is 1, 2, 3, and 4, okay? So usually it's better to start from equation 3, okay? Start from this kind of something times another, okay? Yeah, lambda times y equals 0. Start from 3, okay? And then from here we know there might be two cases, okay? So let's say case 1. Case 1 is that lambda equals 0, okay? So case 1. And of course case 2, y equals 0, okay? Yeah. So case 1, lambda equals 0. What can we do from here? If lambda equals 0, then it is very obvious that equation 1 becomes 2x1 minus 3x2 equals 0. Okay, equation 2 becomes 2x2 minus 3x1 equals 0. Okay, great. Yep. And if you solve this, yeah, like the first equation minus the second equation, anyways, what we have is okay. So finally, you will have x1 equals 0 equals x2. Okay, and in this case, if both x1 and x2 are zeros, then and y squared equals 6. Okay. Yep. So that's the first case. Okay. And basically, you know, if you have this kind of situation, you know that, yeah, let me ask, is the constraint active or not? If you have this kind of situation, I know this is 0, okay? So one more time, after writing down the equations, we start from equation 3, and there are two cases. Case 1, lambda equals 0, okay? With this kind of, with lambda equals 0, we can solve for x1 and x2, okay? Finally get it. And also we get y squared equals 6, and of course y equals positive negative square root of 6. So my question is, in this case 1, is the constraint active or not? Do you guys remember the definition for an active constraint? An active constraint means that this smaller or equal sign becomes equal sign, okay? And in this case, if x1 and x2 are both zeros, then negative 6 is strictly less than 0. So this means that the constraint is not active, okay? So the constraint is not active or inactive. And do you guys remember there's another way for telling whether the constraint is active or not? That is, if the existence of the constraint does not change the solution of the problem, then the constraint is inactive. Okay? 好，我再用中文说一次啊，就是要看一般的人比较简单的定义的方式，就是要看一个 constraint 是不是 active。第一个方式就是看，当你把刚才解出来这一点带回去 constraint， 看是不是刚好等于0。如果刚好等于0的话，代表说这个是 active constraint。OK， 好，那你把刚刚这个解出来这个点带到 constraint 里面，发现它是小于0，那代表这 constraint 就不是 active。OK， 刚好等于0才是 active constraint。那第二个看这个 constraint 到底是不是 active 的方式，就是看这 constraint 的出现会影响你的解吗？那你看这个情况 ，case 1是 lambda 等于0，lambda 等于0的时候，你看根本就lambda 等于0，也就代表说这个 constraint 根本对这个方程没有影响，对不对？所以 lambda 等于0，一看到 lambda 等于0就可以知道，那基本上这个 constraint 就是 inactive。OK？ Yeah. So in this case, the constraint is inactive. But that was the basic definition. Okay, in the class notes, I also wrote down the more detailed or the more strict definition. Okay, hopefully you can take a look. But maybe I can talk about that later. Okay, but let me just continue with this. Okay, so that is case 1. Okay. And then case 2. So case 2, y equals 0. Okay. Yeah. And in this case, yeah, let's start. So let's take a look at equation 4. Equation 4 now becomes x1 squared plus x2 squared equals 6. Okay. And let's also come back here to try to solve or try to rearrange equation 1 and 2. Okay, so let's rearrange equation 1 and equation 2. Okay, so we have 2 plus 2 lambda x1 minus 3x2 equals 0. Okay, and equation 2 negative 3x1 plus again 2 plus 2 lambda x2 equals 0. Okay. You know what we can do is to multiply this equation by x1 and multiply that equation by x2. Okay. 对吧？我们把刚才这边得的这个式子都乘上 x1 哦。Okay. So if we multiply both terms by x1, yeah, 都乘上 x1 应该 OK 哈。And for this one, let's multiply both terms by x2. Yeah, because in this way, it will be easier for solving the problem. Okay. Yeah, and let's call this. So I need to call this equation 5 and equation 6. Okay. 可以吗？上面这个式子都乘上 x1， 下面这个式子都乘上 x2. Okay. And then, yeah, 5 minus 6, and then let's see. Okay. So now we have 2 plus 2 lambda times okay. Yep. I hope that's right. Okay. So 3x1, x2 is cancelled out. Yep. So that's right. Okay. And again over here there are two ways to get. Yeah, I mean there are two cases, okay? So either 2 plus 2 lambda equals 0 or that one equals 0. So anyways, so we can have lambda equals -1. Let's see whether this is fine, okay? Maybe I should say, this is case 2.1, right? Case 2.1, that is 2 plus 2 lambda equals 0.